Well, hello everyone. Professor C is back with Gus doing another chem problem. Sorry if I sound tired for this question. Sorry if I'm tired for this question. I am tired. This is actually my third question because I went to go upload my second one and someone literally finished it 10 minutes before I did and uploaded it first. So doing another one. Try to go through this fast. I'm tired. Anyway, we're doing question 32. Question today goes says 1.3 grams of some unknown compound reduces the freezing point of 75 grams of benzene from 5.53 Celsius to 4.9 Celsius. What is the molar mass of the compound? And it gives us some additional information. The molar freezing point constant of benzene is 5.12 degrees Celsius per molility. Sorry, I'm not saying it. Not molarity, molility. Molility. Moles solute over kilograms of solvent. Sorry. Oh, so the equation for this has to do with freezing point. So the equation for freezing point is change in temperature equals I times sorry, I wrote it down. I times Kf times molility. Molility. Know what I'm trying to say? I mean, literally when I say molility. I'm sorry if I'm struggling with it. So absolute value of change in temperature equals I times Kf times N. So first of all, what is I? Well, when something is dissolved in a solute, whatever, like I don't know, salt dissolved in water, the ions just like NaCl, they separate, right? So there's two molecules in the water. Basically, instead of just one in NaCl, it turns into two. That makes sense. And let's look at benzene. Benzene is C6H6. I think it's C6H6. Anyway, B6 is C6H6. As you can see, it's not an ionic compound, and it's a molecular compound. And usually these do not dissociate in water. So the amount of molecules within the solvent will still be one. They don't break apart, meaning the I is going to be equal to 1. Yep. Kf. Kf is the molar freezing point constant of benzene, which they gave to us. So Kf is equal to 5.12 degrees Celsius divided by molility. Molility is, I'm sorry, I cannot say it. Molility is moles of solute X. I put X because we don't know how much. And it's moles of solute over kilograms of solvent. And they actually gave us how many grams of benzene it is. Because benzene is sorry, I don't know if I specified this, but the compound that reduces the freezing point of benzene is the solute, because it's being dissolved into benzene. And benzene is the solvent, because it's what's the unknown compound is going into. Sorry. So molility is moles of solvent X, because we don't know what the compound is, nor do you know how many moles it is. But they didn't give us the amount of benzene it is, so it would be 0.075 kilograms. So I believe there's 2 ways to do this problem. Yeah, there's 2 ways to do this problem. I'm trying to think. What you could do is you could just plug in all your numbers and you could just plug in all your numbers and then solve for n, or you go ahead and get n alone, because what we're looking for is anything. Sorry, excuse me for a second while I think. Okay, sorry. Let's go ahead. So let's get M alone. To get M alone, we can go ahead and get an I. I is just 1, so it doesn't really need to be there. So we divide by KF on both sides. I'm really sorry. I'm really tired, guys. Not been my week, guys. Now, on my paper, I did it a different way, I think, but this should work out anyway. Sorry. So if you missed what I did was, I divided both sides by K of F, which cancels out here, just leaving this mole literally, and I divided this by K of F. And since we know M is equal to this, I went ahead and expanded into that. And let's go ahead and plug in our numbers. K of F, as we have stated, is 5 point. I'll just leave this equal to M. I don't think it matters. I'm so sorry. And what is our change in temperature? As stated, it went from 5.53 Celsius to 4.9 degrees Celsius. So 4.9. So change in temperature is final minus initial. Final is 4.9 degrees Celsius minus 5.53 degrees Celsius. And I think it's 6.3 or 0.63. Yep, negative 6.3. So the change in temperature is negative 0.6 degree, is negative 0.63 degrees Celsius. However, since we're using absolute value of change, it's going to be positive. So it's 0.63 degrees Celsius. And I'm fairly certain this should work out. So since we're dividing this by a fraction, we move molality to the top like this. Times molality. And as you can see, Celsius cancels out, leaving us with just little n. So the molality is equal to 0.63 divided by 5.12. And this gives us 0.1230 moles of solute X per kilogram. 1 kilogram of solvent. However, as we know, we do not have 1 kilogram of solvent. We have 0.075 grams of solvent. So we can multiply by this 0.075 kilograms of solvent to find out how many moles of solute there is. Units cancel out. I'm really sorry if I'm not explaining anything good. This is not planned. And it's not late. You didn't even notice I'm in a different room as well. Gus, you can have to use that because the other room was taken. So they come to this room. I don't know if it's any better. Sorry, I think the glare may be worse in here. Oh, I'm sorry. We'll just move on. So this will give us 0.0092229 moles of solute. Yep. So there's that many moles of solute dissolved within the solvent. However, what was the original question? Question. The original question was asking for the molar mass of the compound. So it wants to know how many grams per 1 mole. And obviously, that is not 1 mole. So we know we have 1.3 grams. So molar mass, let me erase some of this so I can make room. Forgive me. Yep. Molar mass is equal to moles over grams, or like how many grams per mole, sorry, is equal to gram over mole. So let's go, I guess we just plug that into our equation. Yeah, I mean, we just plug this into that. So we have this many moles, and we have 1.30 grams. And since grams over moles, grams of solute, we have 1.3 grams of solute over 0.009229 moles of solute. And this will give us the molar mass of solute. Okay. And this will give us 140.9 grams per mole. So that is the molar mass of the unknown compound. I'm having fun. Not really. Hold on. Wait a minute. I made sense of stupid stuff. Sorry, this video's gone long enough. That's the answer, by the way. I didn't realize I said some stupid stuff. The molar mass is 140.9 grams per mole. However, so earlier I said I is equal to 1 because. Sorry, I said I is equal to 1 because benzene doesn't just show. When it is dissolved, it doesn't break apart. But I just realized it makes no sense because benzene is the solvent, so it's not breaking apart. The unknown compound is breaking apart. But regardless, so we don't know the I for the unknown compound. We don't know what it is. We don't know if it's like NaCl3, I don't know, just some random ionic compound. We don't know. But we can use this equation regardless to still find little m, if that makes sense. I does not matter to find molecular mass. I'm sorry, that was stupid. I need to clarify. That's my bad. I was not even a factor in this problem. Just ignore it. I'm sorry. Yeah, y'all have a great day. Thank you. Sorry for my rambling. I'm not doing good. Or no, I am doing good. I am doing good. I'm just tired.